Hi, my name is Shri and I'm an 8th grader. And in this video, I'll be talking about the basics of waves. So, a wave is a transfer of energy. Now, let's take a look at the characteristics of waves using this diagram I drew. So, let's start at the small box to the left. It says sound. If there's a higher frequency, there's a higher pitch. If there's a higher amplitude, there's a higher volume. So, what are frequency and amplitude? So, let's start with amplitude. If you can see right above that sound box is amplitude, which is the height of the wave. The arrow stretches from the center or like a middle point to the top. So, that's the amplitude. So, if there's a taller amplitude, there's a higher volume, and if there's a shorter amplitude, there's a lower volume. So to the box to the small box to the right, I drew a picture of frequency. So you can see like that smaller wave is like more frequent than the wave in the background. But how is that so? It's because like at the top, if you see wavelength, where I labeled it wavelength, which is the length of like waves, which is from like the topmost point to the topmost point, like from the crest to the crest, or from the bottommost point to the bottommost point, like from the trough to the trough. So that is wavelength. So a wave with a shorter wavelength has a higher frequency because the waves pass like a specific point more frequently. So those are like the main characteristics of waves. So there are two main types of waves. The first type is mechanical waves. A mechanical wave needs a medium like solid, liquid, or gas in order to transfer energy. Think sound. There are three main types of mechanical waves: transverse, longitudinal, and surface waves. We're going to be focusing on sound waves, as longitudinal waves, um, which are longitudinal waves. So basically, when speakers and other music makers, like instruments, make sound, there is vibration, as all objects vibrate when they make a sound. So when an object vibrates, it disturbs the particles around it, creating sound waves. Those sound waves collide with the particles around them, starting a chain reaction in which particles vibrate back and forth, colliding with more particles, which vibrate back and forth, colliding with more particles again and again. Sound is the energy transfer between consecutive vibrating and colliding particles. Sound waves are longitudinal waves but are often depicted in a transverse form for easier visuals. So the second type of waves are electromagnetic waves. These waves don't necessarily need a medium to move through. They can move through a vacuum. The electromagnetic wave spectrum, or the EM spectrum, is a continuous span of all frequencies for radiation. This spectrum includes many types of waves, such as radio waves and gamma rays. Radio waves are at the far left of the EM spectrum, having the longest wavelength, lowest frequency, and in turn, the lowest energy, because energy depends on the amplitude and the frequency of a wave. So, these radio waves are used commonly for communication via radio because they can travel large distances. Microwaves, the waves, not the appliances, are second to left, having slightly bit more energy than radio waves. They are used to heat food by heating water molecules and even for wireless communication and Wi Fi. Next up, we have infrared waves, which have more energy than microwaves and are commonly used in meteorology. Next up is visible light. So, visible light is a very small section of the EM spectrum, and it is the only section that humans can see. And Yeah, it is called visual light because we can see it. To the right of them are ultraviolet rays, which can cause sunburns and increase the chance of skin cancer, but have important roles in the medical field. After UV rays are X rays that are used in medical imaging, and then finally gamma rays, which are very, very dangerous. Gamma rays have the highest energy of all the waves. They can cause cancer and, strangely, even destroy cancer cells. So are used to sterilize medical equipment. They are used to sterilize medical equipment because they have high energy and they can destroy harmful things. So light is a really big part of the electromagnetic spectrum, and it has many, many properties, including absorption, reflection, transmission, and refraction. So absorption is when light is absorbed into the material. Reflection is when the light reflects the surface of the material, like a mirror. Transmission is when the light goes through the material, and that material can be something like clear plastic. And the refraction is when light appears to bend, like a pencil when you put it in water. Refraction occurs because waves travel at different speeds through different mediums, leading to the pencil to appear bent when half of it is in air and the other half is in water. So that concludes our video about waves. Thank you for watching. Make sure to like, share, and subscribe.